How can you study? Maybe we just use it as an experiment and use high-speed camera and we can study it, huh? But that is expensive. We need to buy a high-speed. Of course, we can borrow it, but you have to pay. The easiest way is study those things using our finger. Yeah? So that means we can make our fingers that can feel the physics. Right? Let's feel the physics from our fingers. Okay, I can see 1, 2 guys, 3 guys are absent today. Oh, poor guys, they will absolutely, oh, 1 guy came in. Where is Yang-Hann Kim? Workshop. Conference is more important than the lecture. You see, I think for graduate students, the course or lecture has higher priority than the conference. Maybe less priority than joining your sister's marriage ceremony, but I mean that is big event. But right? Only once hope, only once in a life. Huh? Only once in a life, right? Only once. Yeah, I hope. I hope. Yeah. Marriage is meeting some very interesting impedance in our life. The wave we have been enjoying has to be changed. Right? Depends on the wavelength. Ka, maybe Kr. I'm going too far. Okay. So let's study this. To understand this, we need to establish the coordinate. So let's say this is okay. Let's say this is a Z. And then I have X and I have Y over Z. Okay? And now I want to predict the sound over here, PR. How can I predict the sound over there? How can, I am asking you, how can we predict sound at arbitrary points R that is induced by velocity that is driven by this piston? Okay, for simplicity, let's assume that we have uniform velocity un, exponential minus j omega t. How can I predict the sound? Maybe a wise guy can say, what is the diameter of this? A. If Ka is very large, then I know the sound over there because that is somehow like a breathing sphere. Then I ask you, can you estimate the sound pressure with respect to arbitrary KR and KA. What would be the way to predict the sound pressure over there? Answer me. Solve linear differential equation. Solve this equation. Boundary condition. This. Solve that equation. Is the another way to get the pressure. Yu-Chung? No? You? No? Green's function. Green's function. How did you know that? Who taught you to? KH integral. Oh, better. Kirchhoff-Helmholtz integral equation. You agree? Why do you agree?
I know the pressure.
Okay. So you agree? Kirchhoff-Helmholtz integral equation? Okay? We are living in a democratic society, so I have to, if you all agree, then I have to follow what you all agreed, right? So let's use Kirchhoff-Helmholtz integral equation. And I can say, I can predict pressure at arbitrary position R by integrating pressure and propagating that pressure with the Green's function and okay, then what is S0 over here? My question is how to apply this famous, well-known, I don't know whether it's well-known, but does not mean that we can use it very easily. How to apply this equation to this specific problem. Of course, some text there is minus 1 over 4 pi, but that can be included in Green's function. We just omitted it, right? How can I use it? Okay, the boundary condition over here is velocity zero boundary condition. Velocity in normal direction has to be zero, right? Okay? So, let me make this surface like this.